Hi, I'm Alan Ross. I'm the managing editor of APC Media, or APC Technology Productions, Transformer Technology, Power Systems Technology. We are here at the RE Plus 2023 event in Las Vegas. This thing is huge. It seems like the battery storage people have come here. So we've got wind, solar, battery storage, and everything in between. But hope you enjoy these interviews. I love interviewing the technology of the future, and enjoy. My next guest is Larry Zulch. We've had an interview before, Larry.
We have indeed.
Yeah, you are the CEO of Invinity. Invinity is an ESS, large storage system. So I want to talk first of all. We're at the RE Plus 2023. It seems like batteries are now everywhere, right? The whole second floor upstairs is battery, battery, battery. A lot of different systems. Talk a little bit about what's changed since the last time we talked a year ago.
You know, there's increasing recognition that when the percentage of renewable energy goes up, when RE Plus is successful getting everybody to do wind and solar, the grid gets unstable if the percentage goes up. And that's when you need energy storage. Stabilizing the grid by making energy that's produced intermittently available 24/7.
And there's a lot of different technologies, but you use the word scalable, right? That's one of the big challenges for utilities, to decide what to do from a scalability standpoint. From a security standpoint, there's a lot of challenges in that scalability. Talk about it.
Well, scalability is important because small battery systems, if you have enough of them, they can make a difference. But right now, with large wind farms, large solar installations, they're making so much energy when the wind's blowing, the sun's shining, they don't know what to do with it all. We're curtailing gigawatt hours every year, and then as soon as the sun goes down, there are shortages. So that is not solved by having a megawatt hour or two. That's solved in the hundreds of megawatt hour range.
Right. One of the problems is capturing that wind and solar. The other problem is using it when you need it and having that, I'm not going to say automatic shut off, but you've almost become, the battery storage area has become the peaker plant of the future, right? Because we're trying to do away with gas peaker plants. But that's an inverter-based system, right? Talk about the challenges that the inverter-based system is putting on the rest of the assets. I know transformers. Transformers are failing at twice the rate they've been failing because of the inverter-based system. A lot of harmonics in the system. Now you're getting a lot of power quality issues. Is that affecting the storage system?
Yeah, you brought up a number of important issues there. And so what I would say is, that we work with PCSs that are designed to fit seamlessly into the larger grid system. But getting the stability you're looking for is going to take energy storage of various types all working together. Like anything else, we tend to look at energy storage in a single sort of bucket, but really there's going to be short and medium and long and ultra long and seasonal, and all of those are different technologies.
So let's switch gears a little bit. Where does Invinity fit in all of that? Okay, this is, you know the market, you've got a solution in the market. The market, as you just said, there's a lot of, where are you fitting into it?
I mean, since we last talked a year ago, Invinity has put in the largest flow batteries in the United States, in Canada, and in Australia. We already had done so in the UK. And what we're doing is demonstrating the commercial viability of vanadium flow batteries to be something that doesn't wear out and doesn't catch fire. Lithium batteries are not perfectly appropriate for stationary use. They're terrific. I have them in my car. I have them in my phone. I have them on my watch. But they're not the right solution, but there has not been an alternative. Even our current product is not a viable alternative to lithium, but we are developing that next version of our product. And that will be one that will be an entirely new ballgame for vanadium flow batteries.
One of the reasons I love talking with you is you have a factory in Scotland. I was born in Edinburgh, so I'm really akin to it. Is that your only factory, or do you have multiple?
No, we build the core of a flow battery is the so-called cell stack. It has the membranes where the electricity is interchanged with the liquid electrolyte, which flows through, hence flow battery. That's our real intellectual property that we've developed. And we do build it right outside Edinburgh in Bathgate. and in Vancouver, British Columbia, which is sort of the center of electrochemical expertise in North America.
Really?
Yeah, it's
I
where
did not know.
Ballard was. It all came out of the paper industry, so a long story, but they developed expertise in electrochemistry to work with bleach to make paper white. That expertise led to fuel cells in Ballard, and then led to flow batteries, and ultimately to Invinity.
That's excellent. That's a nice. That's not. Now, I asked about Bathgate. Where do you have other facilities, manufacturing facilities?
Right, so that's the manufacturing facility, Vancouver and Bathgate. Then we also build the balance of system. You know, the big metal boxes with tanks. The best supply chain in the world is in China. We build them in Suzhou, outside of Shanghai, and bring them in. Although, of course, like everyone else, we're looking at onshoring that capability.
But that's the thing you want to buy from China, because it's not a smart thing, right? It's a box.
It's a
Hey,
big
let
metal
'em-
box with big plastic tanks in it.
And they do build them cheaper and faster
That
and as
they
good as
do.
anybody in the world.
They do.
That's an excellent thing. You talked about the future and what you're developing. Obvious, that's going to be a patented approach,
Yeah, I
proprietary.
mean, for the first time in this show, we're showing Mistral is the code name for our next generation battery, designed to be less expensive and scale larger than any flow battery before.
That's excellent. And that will be coming to market when? How long is it going to take?
End of next year will be first customer ship.
Have you got customers lined up?
Oh yeah.
Okay.
Yes.
You're not allowed
yes,
to
we
share
do.
any of that, are you?
No, I'm not allowed to say exactly who, but what I can tell you is that the interest in it is great, because the limitations of lithium are clear. So therefore, people are hungry for alternatives, and we do have a global engineering firm, a very large German and Spanish firm that is supporting the development of this new product. So when they say this is a great product, and that they've co-developed it with us, we think it'll change the non-lithium storage industry.
And you use vanadium, is that correct?
That's correct.
And vanadium, for most people, if you don't have an engineering degree and you didn't have to take a chemistry course, they have no idea what it sounds like. Sexy, right?
Well, yeah, my daughters say it sounds like it's out of a Marvel movie. Vanadium's element 23. It's an element. It's more common in the Earth's crust than copper or chrome or lithium or many other things. Mainly used to strengthen metals. But it has a unique characteristic. It combines with oxygen, and in multiple ways it combines with oxygen. And when those change, it stores or discharges energy. Similar in some ways to hydrogen, combines with oxygen, makes water, back and forth, that process. Well, vanadium goes through a similar, what's called a redox process, reduction and oxidation. And our batteries take advantage of that.
Excellent. That is a change the world kind of a thing, because there is a limit to lithium. Who owns it? Where is it? If vanadium is as common as copper, that means it's everywhere, which is a great solution for what we're doing.
80% of vanadium is made out of post-industrial processes.
Really?
Yeah, you know, when you take sulfur out of fuel for ships, you run it through a catalytic bed to do that. What clogs the catalyst? Vanadium. As soon as it's useless as catalyst, it's because it's about 18 to 20% vanadium, which is a great source of vanadium, and that's being extracted in the US, in Asia, in Europe, in all over the place.
Oh, that's excellent. Well, that's good. It's good to interview you again.
Thank you for
Larry.
the opportunity to talk with you.
Thank you so much.